Measure twice, cut once. IT Professionals Conference, June 2023.
Hello, and thank you for joining us today for our talk, Measure Twice, Cut Once, How to Add Usability and Accessibility into Your Development Process. My name is Christine Anderson. My pronouns are she, her. I am a Caucasian woman with long dark hair wearing a black shirt and a white blazer. And I'm a user experience architect at the Center for User Experience.
And my name is Maria Damon. I am also a user experience architect from the Center for User Experience. I use she, her. I'm a middle-aged white woman with glasses and long hair.
Slide, agenda. 3 points with subsections.
Today, we're going to talk a little bit about the theory of human-centered design, including usability heuristics, which are best practices for usability, and accessibility, how to use that theory in practice, and then finally the outcome being a digital experience that meets the POUR principles, meaning perceivable, operable, understandable, and robust. And we'll get into more of that soon. So the 10 usability heuristics for interface design are through the Nielsen-Norman group, and I do recommend that you Google 10 usability heuristics and look at the Nielsen-Norman page. They have great little videos on each of these 10 heuristics, but we'll go through them quickly today.
1.
So the first heuristic is visibility of system status. So the design should always keep users informed about what's going on through feedback in a reasonable amount of time.
2.
Match between the system and the real world means the design should have words, phrases, and concepts that are familiar to the user rather than using internal jargon.
3.
User control and freedom. So since users often perform actions by mistake, they need a clearly marked emergency exit to leave the unwanted action without having to go through an extended process.
4.
Consistency and standards. Users should not have to wonder whether different words, situations, or actions mean the same thing. Follow platform and industry conventions. As humans, we do enjoy innovating, but we often do that to the detriment of a user experience when someone is just trying to accomplish something on a web page.
5.
Error prevention. Either eliminate error-prone interactions or present users with a confirmation option before they commit the action.
6.
Recognition rather than recall. The user should not have to remember information from one part of the interface to another. Information required to use by the design, such as field labels or menu items, should be visible or easily retrievable when needed.
7.
Flexibility and efficiency of use. Shortcuts which are hidden from novice users may speed up the interaction for the expert user so that the design can cater to both inexperienced and experienced users.
8.
Aesthetic and minimalist design. Interfaces should not contain information that is irrelevant or just rarely needed. Every extra unit of information in an interface competes with the relevant units of information and diminishes their relative visibility.
9.
Help users recognize, diagnose, and recover from errors. Error messages should be expressed in plain language. Don't use codes. Precisely indicate the problem and constructively suggest a solution for the user.
10.
And finally, help and documentation. It's best if the system doesn't need any additional explanation. However, it may be necessary to provide documentation to help users understand how to complete their tasks.
Slide, accessible design.
We'll talk a little bit about accessibility now. So on this diagram, you see an example of permanent, temporary, and situational disabilities for touch, sight, hearing, and speech. And this is from Microsoft. As an example for speech, we see in the permanent category a person who is nonverbal. Temporarily, a person might have laryngitis. And situationally, a person might not be speaking their native language and therefore have a heavy accent and not be able to be understood. So accessible design supports inclusion for people with disabilities. Accessible design takes into consideration how different people will discover, interact with, and learn from any given resource or information technology. It works to remove barriers to access. Barriers to access are when someone encounters a mismatch between themselves and the environment that they find themselves in.
Institutional Statement on Diversity.
This is UW-Madison's Institutional Statement on Diversity. The University of Wisconsin-Madison fulfills its public mission by creating a welcoming and inclusive community for people from every background, people who as students, faculty, and staff serve Wisconsin and the world. All of the heuristics and knowledge of accessibility is to support inclusion and access for our entire community. Letting people access help and resources and learning in a way that works for them will help them be more successful over time. We hope that you'll walk away from the presentation today with a little more knowledge about how you can enhance the usability and accessibility of tools and products that you build or are responsible for. So we've just delved a little bit into the philosophy of human-centered design, and now we'll move on to the practice.
Slide, in practice.
Thanks, Maria. So in practice, building in a human-centered way, find and design for the whole user experience. Understand the context of the users and the systems. This is sometimes called discovery research. Be clear about the problem that you're trying to solve. Find user needs and requirements. This is business analysis and discovery research. Develop and design solutions that meet those needs. One tool we use are how might we statements. The power of a how might we statement is you take the problem and turn it into a goal. Before you create a solution, think about all the possible ways to solve the problem, to generate more design ideas first, then narrow them down to the right solution. How might we create a more inclusive space so that students feel like they belong at the university? This is ideation and design. Evaluate and test those designs against the requirements. Research that evaluates and usability testing, testing with prototypes with users, and changing based on those user needs will help you create a better experience.
Text, understanding what to do and who is doing it. A handwritten diagram.
There are a variety of ways to include users in your discovery and design process, and it will always make a better product. We are not the users. On this slide, you'll see an image of a design exercise with a group where we take various stakeholders and users and contributors and ask them to come up with the ideas around the tool that we are trying to create. We take all of their insights and do something called affinity diagramming, which is grouping them together to create higher level themes that we can then use to help organize content on a page or think about the functions that need to be available and those great help and resources that we talked about with the heuristics. On the right, you'll see an example of what we call rapid prototyping or drawing sessions. And that just helps us get an idea of what users think that an interface should be organized like, what they need front and foremost access to get done what they need to get done.
The diagram includes several checklists in different areas.
So in practice, digital accessibility. Accessible design is an outcome, but accessibility is within the experience. Supporting navigating via screen reader, navigating via keyboard, and magnifying content as a few examples, we can provide a more equitable experience for all users. Making sure to support these three things, in addition to other best practices, also supports literacy software, which is a very common tool for accommodation planning at the university. The software allows for text-to-speech functionality and does other things like highlight content as you read. It supports students with ADHD, dyslexia, and other intellectual disabilities.
A new slide shows the screen reader in a screenshot. Headers and other design elements are labeled.
Navigating via screen reader. Using the rotor and how semantic heading structures can support navigation. On this slide, you'll see a picture of a web page. I have the screen reader open and I've opened the rotor to allow me to navigate via heading. So there is a list of headings that are on that web page, and then I have some arrows there pointing to corresponding headings to that list. On the right, there's an image of the default heading styles that Google offers when you create a Google Doc. So they have those heading, the semantic heading structure of H1, H2, H3, but they also have stylings attached to them for that visual indication. Navigating via screen reader allows a user with vision impairment to go through the reading order and every bit of content in digital interfaces, but it also affords them the same flexibility as a fully sighted user. Having access to the tab key and various shortcuts, including scanning content by headings or links through the screen reader's rotor, a user is not forced to step through text they don't find useful. WebAIM, a group of developers, individuals with disabilities, and others who share a goal of creating a more accessible internet, conducted a survey of over 1,500 people who navigate the internet via screen reader in spring 2021. Of those, over 50% responded that being able to navigate a web page via headings is very useful. Heading structures is one of the best places to start when making digital content, and one of the things we check for when evaluating. Using the H1 through H6 HTML tags will give the order and context that is needed for screen reader users, but it also will often provide the styling needed for sighted users to navigate.
She goes to the W3C page. A list pops up and she scrolls through it.
So on this slide, you'll see the video shows me navigating via screen reader and opening the rotor to go directly to the heading I want to find to get what I'm looking for without having to step through all the text and content before it.
She chooses an option on the list and the page jumps to a lower section. She returns to the W3C page. The list pops up again and she scrolls through it again. The page jumps to another section with 3 screenshots of a web page with highlights in the top middle on the left, 2 and 1 in the center on the right.
Navigating via keyboard. Let the elements drive the focus by using proper HTML for things like buttons and links. So on this slide, you'll see 3 screenshots of the same web page, and I've highlighted where the focus indicators are for various elements. When a sighted user gets to a web page, they often will look to the main navigation first. To follow that very human pattern, the focus order on the page will enter the main content and then will move to the main navigation, which is shown in that first image on the left. Then through the secondary or utility navigation and into the search function, which is shown in the second image in the middle. And finally into the page content, moving from one interactive or clickable element to the next. Interactive elements have built-in behaviors that will support proper functionality. Using the correct HTML should always be what you do, rather than styling divs as buttons or forcing focus through manipulation of the tab index attribute, which can create confusing experience and loss of context.
Text focus order does not always follow the visual placement. She returns to a W3C page.
You can see me navigating via keyboard in this video and moving through all the clickable elements here and interacting with the same flexibility as I would have using a mouse or a touchpad.
Various sections of the page are highlighted by a blue boundary box as she tabs through the elements on the page. She clicks on one and navigates the new page in a similar manner.
Magnification is the next thing we'll talk about, and magnification allows users to zoom in without losing content. So on this slide, you'll see on the left, there's an image of a web page at 100%, and on the right, an image of that same web page at 400%. When we test for the magnification support, we go to a maximum of 400%. If the content is maintained and does not require a user to scroll horizontally, it is working correctly. You can see a few things here that you probably also recognize from mobile views of web pages. Text has been enlarged and containers either take up more space or stack. The menu has collapsed into a blue square with the label menu to the right, and often you will see a hamburger or 3-line menu in a mobile or magnified view. These are all supporting accessibility, but also support viewing content on smaller screens. Understanding how your content will be accessed when magnified can greatly increase the accessibility and experience for the user.
Slide, in practice, digital accessibility. A bullet list.
So some other common barriers we see are a lack of alternative text. If you choose an image that adds context and meaning to your content, make sure everyone can access that context and meaning. You chose it for a reason. Poor contrast is another one. Ensure that users don't miss content by having the proper contrast in the foreground and background of your page or web content. Dark mode settings will default to light text, and that's a way to accommodate contrast. There are specific standards for how to be technically accessible in this space, and you can test your colors by finding a contrast checker online to use. We often use WebAIM's contrast checker, which is available free of use for anyone. Non-descriptive links are another barrier we see often. Things like click here, learn more. Descriptive links will help users know what to expect. Lighten the cognitive load by having a link tell a user where it's taking them. If it's going to open in a new tab, make sure to indicate that in some way through the screen reader or with an icon. Improperly formatted lists is another one. Properly formatted lists like unordered lists for a group of items or ordered lists for a process or sequence help users create meaning and plan for how to use the content. Think about a recipe website. The ingredients can be an unordered list or bullets, but the instructions have to be ordered using numbers or letters, so a chef doesn't try to ice the cake before they bake it.
A website link, w3.org/WAI/ARIA/APG/.
So accessible rich internet applications, or ARIA, is something that if you are a developer can be really useful in this space. As a content creator, if you're just entering content, this may not be relevant to the work that you do, but as a developer, there are things that we can do to add extra accessibility features to our content. ARIA is a set of roles and attributes that are meant to help make web content and applications more accessible. Browsers convert markup into an internal representation called the DOM tree. Browsers then create an accessibility tree based on the DOM tree, which can be understood by assistive technologies such as screen readers. HTML is very powerful in supporting accessibility, and using components in the way they are meant to be used will produce a better outcome. Again, don't make a button out of a div. When there is HTML that could use a little extra help, that is where ARIA is used. That being said, no ARIA is better than bad ARIA. If you can use a native HTML element or attribute with the semantics and behavior that you require already built in, instead of repurposing an element and adding ARIA to have that accessibility feature in there, then do so. HTML first is always the best way if possible. It's good to note that ARIA being added will not impact the experience for users who do not use assistive technology. It's just adding to that accessibility tree. The link on the slide, w3.org/WAI/ARIA/APG, is a great place to start to learn more about using ARIA.
The outcome, POUR principles.
Thanks, Christine. So by keeping accessibility in mind and usability, the outcome is that you have a digital experience that follows the POUR principle. This is something developed by the World Wide Web Consortium, W3C, as it's also called, and it's an acronym for perceivable, operable, understandable, and robust. So let's go through each of those. Perceivable means that the text alternatives are equivalents for non-text content. Short equivalents for images, including icons, buttons, and graphics. You have a short description represented on charts, diagrams, and illustrations. So if you have a chart or diagram, they're nice to look at, but you want to be sure that the users who can't see the chart are also getting the information. Brief descriptions of non-text content, such as audio and video files, is also important, and labels for form controls, input, and other user interface components. Another element of perceivable that I want to touch on, as it's something that's common here at the university, is scanned PDFs. So if it's a scanned PDF, that's something that assistive technology can't it can't perceive, it can't read the text in it. It is possible to create accessible PDFs, but that's a different topic for how to remediate, but it is part of this concept of it being perceivable.
Slide, operable.
Operable means that functionality is available from a keyboard. All functionality that is available by a mouse is also available through a keyboard, a mouse or a touchpad. Keyboard focus also should not get trapped in any part of the content. You want to be sure that it moves in a way that is expected from one item to the next, and that you can also go backwards as a user, and it goes in the expected order. Finally, web browsers, authoring tools, and other tools should always provide keyboard support.
Slide, understandable.
Understandable means that the text is readable and understandable. Content authors need to ensure that text content is readable and understandable to the broadest audience possible, including when it is read aloud by text to speech. Such content includes identifying the primary language of a web page, such as Arabic, Dutch, or Korean, within the HTML. Identifying the language of text passages, phrase, or other parts of a web page. Providing definitions for any unusual words or phrases, idioms, and abbreviations, and using the clearest and simplest language possible, or providing simplified versions. For web content in general, we're looking for a reading level of about 8th grade. This helps support people who are in distracting situations, people who are speaking English as an additional language. In general, remember that when you're looking at web content, you're typically wanting to get something done, not relish the experience exactly.
Slide, robust.
And finally, we want content that is robust, content that is compatible with current and future user tools. I know it's difficult to predict what the future will bring with technology, but the good news is that if you are building content or building tools that are accessible, you are creating the best solution possible, and it will be most compatible going forward. Robust content is compatible with different browsers, different assistant technologies, and other user agents. Ensure that the markup can be reliably interpreted, for instance, by ensuring that it's a valid markup. Provide a name, role, and value for non-standard user interface components.
Slide, thank you.
Oh, and if you are, going back to robust, if you are a content creator, but not necessarily a developer, you can still help ensure that your content is robust by testing it on additional browsers, looking at it on different devices and browsers. Now we're at the end. Thank you so much. If you have any questions about the presentation, or you're curious about the work of the User Center for User Experience, which includes accessibility, you're welcome to visit our website and fill out a form there. You're also always welcome to email us at centerforux@wisc.edu. Thank you so much for your time.
WISC email address is WISC, University of Wisconsin-Madison.